Everybody. My name's Luke Sleeman. I'm a freelance Android developer. Today, I'm going to be giving my presentation titled, Was It Fragment to Be? Discussing some of the issues and problems with the Android Fragment API. Today's talk is going to be quite technical, and I'm assuming the audience will have at least had a little bit of experience with the Fragment API. That is, you'll all sort of at least know what it is, and have used it at least once or twice in the past. I'm mainly going to be discussing architecture and strategy when it comes to using fragments, but we're also going to have quite a few slides of code in there. Let's start off with a basic definition of a fragment. A fragment is a UI control you can compose to build responsive tablet UIs. Except, no, not really, actually. Fragments are really rarely used for doing tablet UIs. Also, they're a lot more than just a UI control. Okay, let's try again. A fragment is a reusable group of views that we build our user interface with. Except fragments are way more than glorified view groups. And if you treat them as just view groups, you're going to land up in a whole world of pain. Last time. Hopefully we'll get it right this time. A fragment is an application component with a lifecycle. That's all. Just a component with a lifecycle. And while this is a true definition, it's a terrible one. It tells us nothing. Lots of components in Android have a life cycle. You've got activities and you've got services. Why would we use fragments? Already, we're one slide in and we've run into a problem with them. What are they? How should we use them? Why? When? What are they for? And it turns out that none of these questions have easy answers. Perhaps looking at some history can give us some perspective. Way back in Android 2, we wanted tabs inside our apps. And it turns out that putting all the code for the contents of every tab into one activity would become really unwieldy. So Google introduced Activity Group and its subclass tab activity. And what these things did is they allowed one parent activity to contain child activities, basically in this case one for each tab. But unfortunately, the resulting lifecycle interactions were really nasty and really complex, and it was really lacking in flexibility. For example, what happens if you wanted your parent activity to extend something else, not activity group or tab activity? With Android 3, Google introduced tablet support. And they also introduced fragments to try and provide a more sustainable, flexible solution to the problems that Activity Group was trying to solve, and of course, to help us build tablet UIs. And if you look at this diagram, this is really the problem they were trying to solve. This was the whole point of fragments. On the right, we have a phone UI, and on one screen it's got a list, and you tap on something and you'll go to a separate screen and view the detail view for that. Whereas on the fragment, we've got both the list and the detail on one screen, with the list down the left and the detail on the right. And in addition to allowing you to build like fragment tablet UIs, they also added a whole bunch of helpful stuff in there to do with the backstack, fragment transactions, animations. And I sort of say helpful because, of course, it also added a bunch of complexity in there, which wasn't very helpful. And we're really still learning to deal with that today. In the 4 series of Android, Google continued to add new features to fragments and to build things that use them. So, for example, the view pager and the nav drawer are often built on top of fragments. In Android 4.2, they added support for child fragments, so you can nest one fragment inside another. And they also created the support library, so we could use fragments across all of our devices, no matter what version of Android they were running. Now that we have got an idea where fragments came from, let's have a look at some of the issues that they have. Overall, I'd have to say that the biggest problem with fragments is they sort of work most of the time. It turns out that sort of works is the worst kind of works. It tempts you to keep using them. You think, oh, I've just got to fix this one weird edge case bug, instead of thinking, perhaps I should take a step back and try a different approach. Also, because you can build apps with them and everyone is using them, you think, well, perhaps the problem's just me. Perhaps I'm actually a bad software developer. Personally, after 4.5 years of doing Android development, I'm finally starting to think perhaps the problem isn't with me. Perhaps the problem is with the API. Over here, we have the activity lifecycle. It looks a little bit complicated, but as Android developers, we're all familiar with it. It's not that hard. We know how to deal with it, and we can figure it out. And over here, we have the fragment lifecycle. Again, it doesn't look so terrible. In fact, it's simpler than the activity one. But then you realize that the fragment lifecycle has to live inside the activity lifecycle. We need to look at how they interact with each other. Fortunately, somebody has produced a diagram of the two life cycles merged together. Some of you might have seen it before. It looks like this. And it keeps going. And it keeps going. And then on top of that, we have to add in asynchronous fragment transactions and child fragments and view pages, which can cache their state, and lazy construct fragments. And when you add it all together, ultimately it means that we have no idea what state your fragment will be in, or even if they exist at all. This leads to problems with communication. From your fragment, you can never actually be sure if your activity is there. From your activity, you're never sure what state the fragments are in, and you can forget about trying to do fragment-to-fragment communication. Now, a lot of you that are listening to this at this stage are probably thinking, come on, Luke, it's not that bad. If you put some code in the onResume method of your fragment, then you can be pretty sure what state the fragment's going to be in when that code gets called. Well, firstly, I would refer you back to the slide about how it does kind of work, but also perhaps a small example will help illustrate the problem. Here we have some code in a fragment, and part of the code in our fragment is this nice simple helper method called update timestamps. It probably does something straightforward, just updating the user interface or something, and as part of its work, it calls getContext, which could return null if our fragment isn't attached to the activity. Well, this is fine, you think. Let's just make sure that it doesn't get called when we're not attached. But it's not that easy. Update timestamps, being very useful, gets called in a bunch of different places. And then those methods get called by other methods, and suddenly we have this exploding complexity. Looking at the update timestamps method, actually, we've really got no idea when it could be called. And because we've got this methods that call methods that call methods, and we've got like this call stack that could be 5 or 6 calls deep, we really don't know what's happening there. Likewise, with this start data refresh method, it's a public method. We have no guarantees what state we're going to be in when it gets called. And the people using it, the people calling this public interface, they have no idea of what assumptions all of the various methods that start data refresh calls through to will make. Personally, I've been burnt several times by things like this, and this is a very simplified example. If you add in some event listeners and threads that can be going on at random times, you've really got a recipe for disaster. It turns out that Google are well aware of some of the issues with fragments. At the 2016 Google I/O event, there was a great talk called What the Fragment, and they discussed pretty candidly some of the issues with fragments. I pulled a few great quotes into this slide. They said, fragments are so general they become really difficult to explain to people. really, they're a jack of all trades. And Google has deliberately not given as much guidance as developers because they said they didn't want to be too prescriptive and sort of say, we're Google and this is the way you need to build all of your apps. They also said a lot of times you build up a Fragment transaction, commit it, and things work completely differently from how you expect. Yep, I've been there and I've done that. They also said that adding more lifecycle on top of the activity lifecycle made stuff too complicated. Here's a quote, and the bugs didn't help. And really, when you think about how complicated all the Fragment lifecycle stuff is, it's unsurprising that there's going to be bugs in the code. Google is just filled with mere mortals as well, and they sometimes make mistakes in their code too. They also said people think that fragments are just like views. We've got this fragment tag that we can have inside our XML, and really it turned out to mislead people quite a bit as to how fragments should be used. So, what we've been through is really just a grab bag of complaints and gripes about the Fragment API. But if we were to boil it down to the core problems with fragments, it's this. Problem number 0 is that they almost work. There are loads of apps that are built on fragments and everyone uses them. So they can't be that awful, can they? But the lifecycle makes them prone to programmer error. There's no clear use case. Are we supposed to be replacing views, replacing activities? Are they used for tablet UIs? And we have no guarantees about what state your fragment will be in. Given these issues, let's have a look at some best practices. I know a lot of you there listening would like me to come out and say, oh, they're a heap of junk, like don't use them, they're terrible. But I'm very suspicious of absolutist advice. I think we always need some nuance in how we approach things. So I will talk about how to avoid them, but I'm also going to discuss when to use them and how to mitigate the risks if you do decide you need fragments. That said, if they cause so many problems, you really do have to ask, are they worth the trouble? Personally, in my code, I'm always searching for simplicity. Every time I've tried doing something clever, it's always come back to bite me. From that point of view, the simplest and easiest approach to dealing with fragments is just avoid them entirely. I'm going to kick off the discussion with two totally normal screens on a mobile phone. On the left there, we've got like a list view. We're searching for recipes, and then you tap on a recipe and you get the detail. There's actually a lot of people out there who think we should use fragments for these. And I think this idea sort of grew from some of the Android Studio templates, because what used to happen is if you just created a new activity, it would by default just build a fragment that sits inside that activity and gets delegated to for everything and provides the UI. But if we do that, we don't get any advantages of fragments, and we do get all the hassle. Why should we do this? What does it give you? I just wanted to emphasize that there's absolutely no need for fragments in this case. Normal activities are great. Using normal activities, we're forced to decouple the data passing, and we've got no dependencies between our screens. We can reason about our screens in isolation, and we get a whole bunch of stuff like the backstack provided for free. Well, what about doing a tablet UI, I hear you cry? Surely, like, being able to do a combined list and detail view on one screen in a tablet is the whole point of fragments. So if we build these two mobile phone screens using the fragments, when we come to do the tablet UI, it's going to be really easy. Well, firstly, I'm going to fess up to a dirty little secret of Android development. It turns out that nobody, including Google sometimes, bothers to do proper tablet designs. But it does turn out that for this app, we actually did have a full set of tablet designs. It was super rare, but the client wanted it, they invested the time, the designer was really on the ball with it, and we got tablet screens. And in this case, it turns out that the navigation on these screens didn't change at all. we still have one list view, and you tap on something and you go to the detail on another screen. It's just different layouts that take advantage of the extra space, and we could do that fine without fragments. While I did use fragments in this app, there was nowhere that I needed them to do the tablet UI. The tablet UI was done with conditional layouts so that we had different layout on a wider screen. We declared some conditional dimension values, so we used like extra padding and took advantage of the extra space. And even a couple of places we actually had some components where the visibility was conditional on the screen width. So on smaller screens they weren't there, and on larger screens they appeared when we had the room to display them. What about as composable parts of our UI? So for example, we have got the ingredients over here and the methods there on this particular screen. Why shouldn't we use fragments to group together a whole bunch of views and their associated code and logic? Well, it turns out we can already group a whole bunch of views together using a view group. It's very straightforward. We just subclass linear layout or flow layout, and here's an example of how that's done. We see this on the screen. We've got really a very complicated view, something for which you might normally use fragments. We've got like a profile image, some title text, some body text, and so on. The thing is, there's no need to use fragments for this. We have no interaction with the lifecycle here, so it's much simpler just to subclass linear layout. Here's the start of the class. You'll notice that here we store references to each of the child views that we're going to need. And in our constructors, we call this init method. Inside init, which is called by those constructors, we essentially inflate the XML UI, and then we look up all of those key views using find view by ID. We also have a set user method where we pass in the data to be displayed in our view, and that loads up the images and sets up the text and so on. Here's the XML layout for our custom view. Again, there's nothing super exciting. We've got image views, text views, and so on. One thing you might notice is there's actually a bit of a bug. We declared linear layout as our root, but then our user summary view also subclasses linear layout. So actually, we're going to land up with two linear layouts nested one inside the other. If this really concerns you, it's very easy to go through and replace the root of our XML with a merge layout. And here that is. You'll also note that we have added this parent tag and orientation tag, which makes sure that our visual preview inside Android Studio is going to work well when we're using the merge tag. And here we're using the user summary view in one of our activities. Again, we've got nothing exciting. We're just using it there inside the XML, and then in the onCreate method, we get a reference to it and we set the user in for it to display. And if all this code looks boring and you're finding yourself starting to tune out, then great, that's the point. We don't need fragments for this stuff. It's super easy to do without them. Subclassing and creating our own view groups is much more straightforward. Another area where you'll often see fragments used is in implementing the navigation for apps that use slide-out drawers. These have gone a bit out of fashion recently from a usability perspective, but they're still out there and we need to be aware of them. Typically, the way these are implemented is you would have a activity that contains the drawer and then a main content area of the activity, which would be showing a fragment. And you'd switch out which fragment was visible based on what the user selects there in the drawer. It turns out it's actually easily possible to do this with activities. Let's have a look at some code. The first bit is our activity class. We're going to want an abstract superclass that contains all of the code related to the drawer and that all the activities containing a drawer can extend from. We also have a method that gets called whenever the user clicks something on a drawer. It builds up an intent for the activity we want to launch and is sure to set the flag activity clear top. It closes the drawer, and once the drawer is closed, it starts the new activity, overriding the animations. You're probably not going to want to keep the default activity transition animations. If you're using the draw, it looks a bit weird. So this is what we're doing with the animations. They just adjust the alpha of the activity moving in and out and slide it a bit. And the end result looks pretty slick. And I'll tell you a little secret about this. The users can't tell and they don't care that we're not using fragments. But from the coder's point of view, we've saved ourselves a lot of hassle. Each one of the screens is totally isolated from the other. We don't need to worry about the fragment lifecycle, coordinating them, asynchronous fragment transitions, or any of that. View pager is another very common use case for fragments. And they're often used to do like view pages in combination with a tab. Here we've got an example of just a simple view pager. It's just a slideshow that flicks between each page. It turns out for simple pages like this, you don't need fragments. These views are static, they're not complex, there's no problem keeping them all in memory at once. The problem is the default view pager uses fragments. So people tend to think that they need fragments to do view pages. It's not true. It's very easy to make an adapter which just works with views. And on this screen, we show the code for the one I actually used in that app we saw previously. It's really straightforward. It fits on one slide, which is amazing considering it's Java code, which is very verbose. Basically, in the constructor, we pass in a list of the views that we want to display, and then in instantiate item and destroy item, we just add them into our UI and remove them. If we wanted to do a little bit more work, we could like lazy construct the views inside instantiate item if we didn't want to keep them all in memory at once or something along those lines. Sometimes another reason people use fragments is to keep long-running background tasks around when the device is rotated. For example, if we've got like a network request going on, we're supposed to keep that network request running even though the user rotates the screen. And the way that's achieved is we have a fragment hold on to the network request, and we call this method called setRetaininstanceState on our fragment, which means that that instance of the fragment will be kept around when the screen is rotated and the activity is destroyed and recreated. So because it holds on to the network request, that doesn't like trail off there in the background. And here's the bit where I get to confess in front of you all that actually perhaps I'm a bad dev, because actually I don't keep my network requests running when the screen gets rotated. I just cancel them. Actually, for short-running tasks, this is probably going to be just fine. Your network requests should only take a second at the most, and if they're taking longer than that, then firstly, you need to look at optimizing them so they can run a lot faster. But also for long-running tasks, you probably should be doing something a bit more advanced than just blocking the UI and showing like this little loading spinner. The Facebook app actually shows a great example of this. When you go to post a photo, it starts up a background service to upload the photo, which means that we're going to have a system tray notification that we can watch the progress from. And it goes immediately back to your timeline where you can view that photo grayed out and the loading process. And like, this is not using fragments and setRetaininstanceState. It's something a little bit more complicated, but it provides a much better user experience. The other thing about using setRetaininstanceState is it's really no silver bullet to having to deal with the activity lifecycle. We still need to be able to handle all of that state saving and state restoration in our UIs anyway, because the app can be destroyed when it's put into the background. It's no silver bullet. It doesn't give as much help, setRetaininstanceState. Lastly, you may be asking, what about some of the more complicated things fragments provide, like our lifecycle and our navigation? Now, personally, I can't say I've ever really had a big problem with these things. Just using activities to build my app seems to work well enough to solve these issues for me. But perhaps that's a bit of a result of the kind of apps I tend to work on as a freelancer. Nobody's pulling me in to work on like a huge 10-person app that's going to be developed for years and years on end. Those kind of people typically have like a big team of in-house developers rather than just pulling in one freelancer to do it. So I am usually working on the smaller side of things. If you are having problems with these, it seems like a library called Flow and another one called Mortar, both provided by Square, are a very popular alternative. They're two complementary libraries which work really well together. Personally, I've never felt the need for them, but a lot of people do seem to think that they're pretty awesome if you start Googling for it. The Flow library is all about managing these kind of conceptual screens and the navigation between them. In Flow, you would typically have one activity that contained multiple screens inside it. And taking this to its most extreme, we may only have one activity inside the entire application. The screens are defined by keys, which are essentially just POJOs, plain old Java objects. To navigate to a new screen, we do flow.set. We can then call flow.goback to go back, and there's a whole bunch of other stuff in there for managing our history and so on. And it looks really powerful and very flexible, even more so than what we have with our activity backstack. According to their Git repo, the Mortar library provides a simplified composable overlay of the Android lifecycle, which actually, I don't know about you guys, it doesn't mean too much to me, but it seems to be doing a lot of different things around Dagger and injecting components. But what's important for us when we're looking at getting rid of fragments is it can provide us a way to create these things called presenters, which are an object that we're going to associate with a custom view. And the key thing about presenters is they have a life cycle, and a life cycle that's a lot simpler than fragments. They can also survive the orientation changes when you rotate your phone, which is very helpful as well. And when you combine Mortar and Flow together, you have everything you need to build a fragmentless application. We've seen that under a lot of cases, you don't need fragments. So when should you use them? And how should we mitigate the risks if we do use them? A lot of the advice I'm about to give is taken from Google's presentation, What the Fragment, from Google I/O. I really highly recommend listening to it. And while Google can't just come out and say, sorry guys, fragments were all a huge mistake, just sorry about that, our bad. What they did come out and say is that they're aware of the issues with them, they're working hard to both fix the bugs in them and better explain how we should use them. So according to Google, what is a fragment? Well, they said that they're roughly equivalent to an activity in terms of level of abstraction. That means they're definitely not views, they're a bigger thing. They're also part of the whatever in model view whatever. So if you're doing model view controller, fragments may be your controllers. If you're doing model view presenter, they're going to be the presenter. A direct quote from that presentation, seriously, they're not just fancy view groups. And they also said, don't use a fragment when a view group or an include will do. Another really key thing I took away from that presentation was fragments are supposed to provide the glue and coordination of components driven by the knowledge of the external life cycle. There has to be some element of life cycle in there. And this is really the answer to when we should use fragments. It's when you have a component that needs to have a life cycle. If you're not doing something interesting in your on resume or on pause method of your fragment, then perhaps you shouldn't be using a fragment in the first place. Similarly, if you're just going with custom view groups and you're finding yourself wanting to access your activities on pause and on resume, then perhaps it is fragments that are what you're after. Here's an example of an app I built using fragments, actually. The tabs in the view pager are done with fragments. And actually, this app was easy and it worked well. And I think the key thing about why this app came together so easily was how isolated the fragments were from each other. None of them talked to the activity, and none of them talked to each other. But they did use the lifecycle methods on resume, on pause, to deal with refreshing data, to deal with UI changes and cleanup. This matches up really well with Google's advice. They said try and keep each fragment isolated. Make sure that your thinking is just scoped to the fragment. Make sure it's not trying to take on responsibilities outside itself. They also said don't go fishing. Once your fragment gets connected to the activity, don't go rummaging around in the activity and the other fragments trying to get handles to things and call methods and control stuff. And this point about not going fishing is really well made. Personally, where I have run into problems is where fragments try and do stuff with each other or their parent activity. They work best when they can be decoupled from their surroundings. This means you need to be very wary of dependencies. And Google actually pointed people towards the documentation of the fragment on inflate method. And if you actually go there and look at it, there's this really great code sample in there of passing information into a fragment using either the fragment's XML attributes or the fragment arguments. It's a very good and straightforward way of getting the info you need into your fragment for it to be able to work. As part of their presentation, Google also said, don't worry about the huge lifecycle diagram. They've seen it. Nobody understands it. Nobody needs to understand it. The code that you see here is taken directly from the Fragment source code. Essentially, Fragment can only ever be in one of these 6 states. So Google said, don't worry about the state transitions. Just worry about what state your fragment is in and what you can depend on being there when you are in that state. Now, actually, I've got to mention that in this case, I do not agree with Google. It's nice that we don't have to worry about that big, scary state transition diagram, but I think in this list, we've probably still got about 5 states too many there. If we have this issue, as we've seen, of methods that call methods that call methods. We've got listeners that can be firing off at unexpected times. We could have people calling in from outside our fragment, communications with fragments, background threads, and they still make the lifecycle incredibly hard to deal with. Google has also worked really hard on fixing up many of the bugs in the Fragment API, making it easier to use. We should all definitely be using the support library. Google has put a bunch of fixes in there, including they fixed up the fragment manager state when inside the child fragment manager state. So inside your fragment's super.onCreate method, once you call super onCreate, the state is guaranteed to be good. They fixed up the fact that execute pending transactions didn't do all the pending stuff for child fragments. Again, it's going to make things easy to use. They've added in a method to fragment transaction called commit now, which is very helpful. Previously, the only way to force the transaction to occur was to call the method on the fragment manager, which committed all of the transactions. So other third-party libraries and components could have queued some up, and you'd really stuff it up by telling the fragment manager to commit. And they also added some more lifecycle methods. Great, just what we needed. A fragment on attach fragment method, which gets called when it gets attached to the activity. And they said that's a really good time to perform some setup, construct listeners, and so on. Lastly, I wanted to finish up with one last pro tip. Everyone should definitely test their app with the do not keep activities thing in developer options turned on. In Android, when your activity goes in the background, it's actually kept around for some time. Eventually, the OS, though, will need the resources and destroy your activity. But it can be quite a while until that happens. It makes it very hard to test the full range of the lifecycle methods. Ticking do not keep activities forces that to happen as soon as the app goes into the background. It's incredibly useful for finding lifecycle problems with your fragments. One thing you need to be aware of, though, is this will just close down your activities. It will not close down the entire app itself. So if you're keeping stuff in a wider scope, in the application scope, that you need to test being there and not being there, you're also going to have to manually go to the task manager and swipe away your app and remove it. let's wrap up. What have we learnt? Firstly, we should treat fragments with respect. They are dangerous. Particularly the life cycle, child fragments, and fragment transactions all combine to cause issues. Also, the lack of a clear use case causes architectural problems. How should we use them? When should we use them? Where? One answer is don't. You can probably get by with a lot less fragments than you think. You don't need them for normal activities. You don't need them to do tablet layouts or responsive UIs. You don't need them as composable UI building blocks. You probably don't need them for drawers and view pages and retaining instant state either. If you do have to use them, make sure you don't treat them like view groups. That's not what they are. Keep them isolated. Don't let your fragments take on responsibility outside itself. Use the support library. And lastly, we know that the lifecycle causes problems. So try and reduce its impact as much as possible, both through your architecture as well as being very defensive in your fragments coding. I hope what I've presented is of some use to you all, and I hope we can use it to improve the quality of our apps and also avoid a whole bunch of headaches. If there are any questions, please ask them in the YouTube comments, and I'll make my best effort to get back to you and answer whatever you have to ask. Thank you.